See, one more thing, here there is a normal reaction also. If normal reaction. So I will add normal reaction here, normal reaction here. Okay. So that will be equal to what? F sin theta plus mg equal to n. Here F sin theta plus n equal to mg. N. Here n is the normal reaction. N is the upward force. Yeah, I think you know about the normal reaction, right? Suppose you are sitting on the chair. Now, if only one force, weight is acting downwards, only one weight is acting downwards, it has to sink in the ground. But it doesn't happen like that. So you are stable on the chair because there is one more force. Normal reaction is acting upwards, equal and opposite force acting upwards. That is the reason. So
yes, sir.
Weight W equal to mg is balanced with the normal reaction. Here we forgot to add normal reaction. And so what will happen now? F sin theta plus mg equal to capital N. Here n plus F sin theta equal to mg. So here these two forces are equal to normal reaction. Here these two forces are equal to the weight. So that is the reason. So upward force is more than the downward force. Here downward force is greater than the upward force. That's the reason. Like pulling is easier than pushing. Clear? It's easier to pull than push. So in work energy part chapter, he starts with dot product. Okay. So in motion in a plane chapter, motion in a plane lesson. Okay. Motion in a plane lesson, we have what we were doing is dot product and cross product. That is vector multiplication. Okay. Vector multiplication. So what is there in this lesson? First, we'll start with the dot product. Then we have work done by a variable force, work done by a constant force. Spring mass system is there, the derivation is there, and conservation of energy and different forms of energy. Last is collisions. Collisions 1 dimension and 2 dimension. 2 dimension they won't ask, but 1 dimension is important. If you even if you're going for appearing for a NEET examination or IIT and all, last part is important, especially the collision thing and the spring thing is important. Now, so vector multiplication. So in vector multiplication, we have scalar product and vector product. So we have scalar product, also known as dot product. Scalar product or also known as dot product. Second one is vector product or cross product. Vector product or cross product. Okay, scalar product or dot product, vector product or cross product. So here we start with the dot product because this is in next lesson. This is not now. We are going to only study about the scalar product. Vector product is in the next lesson. That is rotational motion chapter. Now, suppose there are two vectors. Vector A, this is vector A, and vector B, which is making an angle theta. Okay, I'm going with the scalar product, not vector product. Okay, scalar product. Now, so what we are doing is this is vector A, this is vector A, and this is vector B, which is making an angle theta with the horizontal. Now we are taking the whole thing is vector A. We are taking the projection of B on A, means like this. We are taking projection of B on A. So what happens here when we are taking projection of B on A? So what will happen? This is B cos theta. Understood now? The whole thing is A. And this part is B cos theta. How come? Like suppose if this is B, there are two components, right? Horizontal component and vertical component. If this is theta, so this will become B cos theta, and this will become B sin theta. Is it clear? B cos theta and B sin theta.
Yes.
So B cos theta is that. No. So we are taking these two components together. How come? See here, A into B cos theta. So this is known as A dot B. This is known as A dot B. Is it clear? This is known as A dot B. A into B cos theta will become A dot B. Now, so here we write here A dot B equal to AB cos theta. See, if you are writing modulus in vectors, if you are writing modulus of A, it can be written A. Is that clear? That's the size. Magnitude, either you write like this or either you write like this, is same. Doesn't change. The value doesn't change. A dot B, we can write like this also. Modulus of A, modulus of B, cos theta. You can write in this way. If I want to find out the angle, how do I do that? So cos theta equal to A dot B divided by mod A mod B. A into B. Mod A into mod B. This is the way we find out the angle. Next is what? A dot B is equal to what? This is commutative property. So commutative property, what it says? Commutative property, what it says?
A dot B is equal to B dot
B dot A. A dot B equal to B dot A. Okay. Now, and also A dot B plus C equal to distributive property. Distributive property. Distributive property. It says that A dot B plus C equal to A dot B plus A dot C. A dot B plus A dot C. Now, here we have suppose. Now, here we have three components: origin, x-axis, y-axis, z-axis. So I cap. Next one is j cap. This is k cap. What are I cap, j cap, and k caps? What are I? Very good. So I cap is unit vector along x-axis. Unit vector along x-axis. Similarly, j cap is unit vector along y-axis, and k cap is unit vector along z-axis. Yes, z-axis. Now he says that. Okay, so first copy is, then we'll go to I dot I and I. Okay, we'll do a numerical. Is it clear, girls?
So I got disconnected. I was not there when you started this.
Okay, from the beginning, once again, see, vector multiplication, there are two ways of multiplying vectors. One is scalar and the second is vector. So scalar is known as dot product, vector is known as cross product. Dot product, now we are doing. Cross product we do in the next lesson. That is rotational motion chapter. Now in scalar product, there are two vectors, A and B. Now draw these two vectors, A and B. Here this dotted line is the projection. This dotted line is known as projection of B on A. Projection of B on A. So this will become A and this will become B cos theta. So A into B cos theta is equal to what? A dot B. A dot B equal to AB cos theta. That is equal to A into B cos theta cross multiply A dot B divided by mod A mod B. Commutative property A dot B equal to B dot A. Distributive property A dot B plus C is equal to A dot B plus A dot C. Now there are three vectors X, Y, and Z. I cap, J cap, and K cap. I cap is unit vector along X axis. J cap is unit vector along Y axis, and K cap is unit vector along Z axis. Is it clear? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Please copy this, then we will go to the next one. See here, again we are drawing this. Origin, x-axis, y-axis, z-axis. This is I cap, unit vector along x-axis, j cap, unit vector along y-axis, k cap, unit vector along z-axis. Now, I dot I means what? I into I cos theta. In simple words, we write here I modulus of I cos theta, cos 0 degrees. What is cos 0?
1.
1. So that will become what? I value is 1. I value is 1. Cos theta value is 1. So answer is 1, right? Is it not?
Yes.
So we simply write I dot I equal to J dot J equal to K dot K equal to 1. Finish. Now what happens? I dot J equal to J dot K equal to K dot I equal to what? 0. Why 0? Angle between I and J is 90 degrees. Clear? Angle between
Yes.
I and J is 90 degrees. Clear? So 90, 90, 90. So I dot J dot K and K dot I equal to 0. Understood? Now, next case, we will try one numerical here. Now, we have a example. So we have a equal to vector a equal to ax into I cap plus ay into j cap plus az into k cap, and vector b equal to bx into I cap plus by into j cap plus bz into k cap. Okay, so these are the two vectors. Now I want to find out a dot b, which is equal to what? Ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap. Now see here, I dot I will become 1, right? I dot I will become 1, whereas I dot j will become what?
0.
0, right? I
Zero.
dot j will become 0. Understood?
0.
Okay, and
Yes, sir.
I dot k also will become 0. So that is why we are taking only ax into bx plus ay into by plus az into bz. Understood now? So this is the value now. I want to find out modulus A
Yes.
to modulus B. So this is A dot B. If I want to find out modulus of A, so how do I do that? Under root of, it will become ax square plus ay square plus az square. Similarly, modulus B equal to under root of bx square plus
bx square plus
by
by
square plus bz.
plus bz square.
bz square. Okay, so that is how we find out the modulus. If you want to write the angle, then cos theta is equal to the whole thing divided by this. Understood? So we'll try a numerical on this. So one question here, f is equal to, he gave the product, f is equal to 3 I cap plus 4 j cap plus minus 5 k cap, and d vector equal to 5i plus 4j, 5i plus 4j cap minus 3k cap, Now, what will happen here? F dot D. F dot D equal to what? So we write here 3i plus 4j minus 5k dot 5i plus 4j minus 3k. So F dot D equal to what? 3 5 is 15 plus 4 4 16 minus plus 5 5 3 is 15. So how much it is? 30, 40, 46. 46. Now, modulus of f is how much? Under root of 3 square, 4 square, 5 square. 3 square plus 4 square plus minus 5 whole square. So that is root 50 something. 9 plus 16 plus 25.
So can you explain the I cap into I cap part?
This I cap I dot I is equal
Yes.
to what? See, between the two, suppose if you are taking two vectors on the same x-axis, what will happen? Angle is 0 degrees, right? So I dot I is what? I into I cos 0. Angle between both the vectors is 0 degrees. So cos 0 is 1. Understood now?
Yes, sir.
Okay. Now D here is how much? Equal to under root of 5 square plus 4 square plus minus 3 square, which is equal to root 15. Understood now? Did you understand this concept? This part? Is it clear? I dot I is equal to I into I cos theta. I is 1, then cos 0 is 1. Is it clear?
Yes, sir. So
Okay.
the last part, I into j, can you tell that again?
Where? Here? This one?
Below that.
Below that. I dot, see what will happen? Angle between Now, see, I dot I angle is 0 degrees. I dot J is equal to what? 90 degrees. I dot J angle between I and J is 90 degrees. Understood? Angle between I and J is 90 degrees, J and K is 90 degrees, K and I is 90 degrees. So what will happen? Cos 90 will become 0. 0 into something will become 0. Is that clear?
Yes, sir.
Okay. So now what will happen here? F dot D. See, 3 into 5, 15. 15 I cap, I into I will become 1. 3 into 4, 12. But I into J will become 0. That is why we are not doing that. Got it? See, 3, 4, 3, 5 is 15, done. But we are not multiplying 3 with 4. 3, 4 is 12. Why? Because I dot J will become 0. Got it? Is it clear, girls?
Yes, sir.
Now, 3, 3 is 9. 3, 3 is 9. 9 is what? Again, I dot K is equal to 0. Okay, got it? So we are finding F modulus of F and modulus of D. Is it clear? Is it clear?
Yes, sir.
Okay, just copy this. Then we'll go ahead. The next. So here we have cos theta. Cos theta equal to what? F dot D divided by modulus F into modulus D. So cos theta equal to what? So F dot D equal to what? 46 divided by root 50 into root 50. So cos theta equal to what? 46 by 50. Now, so theta equal to what? Theta equal to cos inverse of 46 by 50. Okay, here. So that's the thing. So if you see the angle here, how much it is showing? 0.32. Is it 16? Let me see. 16 or is it 46? 1 second. 5 3 is one is okay. There is a mistake in the question. I think. 1 second. It is he has taken positive. Here there is a mistake in the question. Okay, in the textbook. Okay, this should be plus. This should be plus, and this should be minus. So answer is 16. So this also will become 16. This will become 16. This will become 16. Then so 0.32. Theta is equal to cos inverse of 0.32. So theta equal to so that's it. Okay. So there's an angle. Okay. Copy this, then we'll go ahead now. So take here F is equal to what? F equal to 3I cap plus 4J cap minus K cap. Similarly, D is equal to minus I cap plus 3J cap minus 4K cap. Find out F dot D. Also find out angle theta. Okay, this is a homework. Okay. Try this question as homework. Is it clear?
Sir, it's minus I cap, right?
Once again, see 3I cap, 3I cap, 4J cap minus K cap minus I cap plus 3J cap. Okay, understood? So copy this. Done? Okay, we will go to the next concept, that is work done. Okay, work energy theorem. Clear? So
Yes.
work energy theorem. Work energy theorem. See here. See, we have in work energy theorem, suppose it says, okay, the statement says the change in kinetic energy of a particle, the change in kinetic energy of a particle is equal to the work done on it by the net force. So now see here, there is a body whose mass is m and whose initial velocity is u, final velocity is v. Initial velocity